a small video on the electric cycle which we built, and there it is. It goes through the basic structure of the bike, which is the motor, the gearbox, final sprocket, the battery compartment on both sides, charging bay with a switch in it, the electronic control circuit which contains the electronic speed, the varying, the potentiometers, the switch there, and right here we control the speed of the motor. This is the basic setup. This is a wattmeter to get the telemetry out. You can do your calculations and endurance and what's not. You will notice this motor looks familiar because it's not a motor, it's actually a Maruti 800's alternator, and you can see that by the fan. This is a one-way sprocket so that while the speed is achieved, you don't have to, while you cycle, that doesn't spin. So the basic setup is very simple. Turn it on, system comes on, runs at 55, but right now it's not being used, so it's not charged. It's at 48.7 volts. This is where you can read the telemetry which cycle it's. This is your system voltage. This is your watts being consumed right now. This is your amp hour equivalent. This is your current, voltage current, watt hour, and watt hour or amp hour. So, in terms of structural insight, construct a vehicle where it's not all top heavy, because what happens is your center of gravity is above your wheelbase angle. So this height, the more it increases, the more unstable it gets, top heavy, right? So that's a challenge. So all this weight should come down ideally here. That's something to remember. Of course, this is a prototype. I just built it for the sake of building it, not even prototype. Alright, the chain have been taken out for the purpose of running the motor. This is a chain tensioner. This is also machined out. In hindsight, you can get this from prefabricated. The ratios of the entire system is 1 to 3 to 5. So effectively 50 close to 16:1 ratio. So 16 times the motor spins, the wheel spins once. Individually you can pedal as well, and you can proportionate the bar here. There are electronic 2 gears, so first and second. Sorry about the mess, it looks a little dirty. So the first gear gives 12 volts directly to the armature. A second reduces the voltage, hence increasing the speed. I will demonstrate that right now. So first gear, and I'm getting a little power. Voltage is dipping, it's climbing. And that's the maximum the first gear can go. No, this potentiometer is like a speed regulator. Now it's at maximum. Same first gear. I jump to second gear. So ideally second gear has to be pushed when you're So that was second gear, reaches at close to 4600 rpm on the motor, which is ratioed down to 16. You can do the math, and that's how this works. In terms of efficiency, we're getting 14.7 watt hour per kilometer, which is pretty good. With these batteries, which are 12 volt, and four of them, they are 7 amp batteries. So that is bad because they are lithium, correction, they are lead acid batteries. So each battery weighs 3 kilos, 3 into 4, 12, and that's the bulk of the weight of the system. This, sorry about that, I just got my tea. Yeah, as I was saying, the subframe, this part was machined. This part here is machined, and it's made out of mild steel, correction, stainless steel, and it's fabricated. If you can see, they are adjustable in tilt and X and Y. Also, this controls the tilt, so chain tension and XY orientation also, to get the motor right on the tracting end. Apart from that, if you guys need more details, let me know. I need to convert something like this into something more seamless and effortless like that, but that's gonna take some more effort. So yeah, this is the basics of it. 1 divided by 0 equals